Hi, everybody. Oh my goodness, trying to expand. There we go. Okay, we're going to get started. We have talked about corresponding angles, alternate interior angles, same side interior angles, and alternate exterior angles. And so what we're going to do now is we're going to talk about using those in proofs. And there's these things called the converse. So if I know that the regular corresponding angles means that I've got two parallel lines. So the regular means that I have parallel lines. Then I say that the corresponding angles are congruent. The converse means if two lines and a transversal form the angles. So the converse means that if I've got corresponding angles, then the lines are parallel. So it's basically reversed, it's switched. So the converse says I first need to know that I have corresponding angles, then I can say, oh, the lines are parallel. Whereas what we've done so far is said, if I have parallel lines, then corresponding angles are congruent. Alternate interior angles, the regular, is if I have parallel lines cut by a transversal, alternate interior angles can be formed. Alternate interior angles are congruent. The converse is if two lines and a transversal form alternate interior angles that are congruent, then the lines are parallel. So the converse of these means that I'm proving that the lines are parallel after the fact, okay? So here's my 1 and my 2 congruent. Here's my 1 and my 2 congruent for corresponding, okay? All right. Let's move on to same side interior. Okay, the regular was, if I have parallel lines, then the same side interior angles are congruent. The converse says, if two lines and a transversal make same side interior angles that are supplementary, then the lines are parallel, okay? So there's that, that's good. Last one, alternate exterior angles. So this would be 1 and 2 equal 180 degrees. Okay, converse of the alternate interior angles. The regular said, if I have parallel lines, then alternate exterior angles are congruent. Converse, if two lines and a transversal form alternate exterior angles that are congruent, then the lines are parallel. That's 1 and 2 right here. Those are congruent. All right? So now what we're going to do is we're going to move on and we're going to talk about some examples. We're going to save these until tomorrow, but until the next lesson, I mean. But we can do these 3 right here. Okay? Here we go. All right. So, okay, a flow proof. A flow proof is written words, but like a flow chart has arrows. This is going to have arrows. So here's what a flow proof is. It uses arrows to show connections. So here we go. I know that angle 1 is congruent to angle 2. That's given. So I'm going to put the word given underneath it. What else can I use in this? 1 and 2 are congruent. They're all, that's given. We know that because we're told, but then, you know, it's alternate interior angles. But if I've got this angle 3 in there that I've got to talk about, then I can talk about 3. 3 I can talk about with 1. 3 I can talk about with 2. But remember, my job is to prove alternate interior angles theorem. So what I'm going to do is I'm going to talk about right now 1 and 3. So if I want to talk about 1 and 3, then I'm going to say another reason that I could give in my, if I were doing like a 2-column proof, it would be angle 1 and is congruent to angle 3. And I would say vertical angles are congruent. And I've forgotten E, but vertical angles are congruent. Those two things right there are going to help me prove alternate interior angles. And then I have to say that the lines are parallel. My end game is, because I have alternate interior angles, then the lines are parallel, right? So a flow chart, a flow proof is going to draw arrows, and I'm going to say that angle 2 is congruent to angle 3. And I'm going to say that by transitive. Okay. Remember, the converse of things means first you prove that something's congruent, like 2 and 3 right now are corresponding. So in order for me to prove the alternate interior angles theorem, I can't use alternate interior angles in my proof because I'm trying to prove that they're alternate interior. So what I'm going to do is I just talked about 2 and 3 because I'm going to prove corresponding. Here's my last. L is parallel to M, and I say the converse of the corresponding angles theorem. The converse of the corresponding angles theorem. So real quick, I had to prove that I had corresponding angles, and then I wanted to prove that 2 and 3 were the same, corresponding angles, and then I could say that the lines are parallel. So I'm going about this very backwards, okay? So here we go. There is a typo on number 2, so let's fix that, please. My given is going to be that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. Okay. So I'm trying to prove the same side interior angles, but I can't use same side interior in my actual work right now. So write what you're given. Flow proof. Measure of angle 1 plus the measure of angle 2 equals 180, and that's given. Okay. 1 plus 2 makes 180. Great, we've talked about that. What can I do with 3? What can I say about 3? Like, why is 3 important? 3 is important because, well, I've got 3 could be congruent to 2 corresponding angles. 3 and 1 are a linear pair. So I'm actually going to say like both of those things. I'm going to say measure of angle 1 plus the measure of angle 3 equals 180, and that's a linear pair. A linear pair is when they're like side by side, okay? So supplementary angles sometimes aren't touching. So I could have 2 supplementary angles that like have a gap between them, like this angle and this angle, but they have like a space between them. They still add up to 180. So sometimes supplementary angles aren't touching, they don't have a common side, but linear pair always have a common side. Now these two are going to lead me to say, look guys, 1 is the same with these, 180 is the same with these, 2 is equal to 3. 2 is equal to 3. Measure of angle 2 is equal to measure of angle 3, which is transitive property. But then Angle 2 is congruent to angle 3 because I went from equal sign to congruent, equal sign to congruent. That's going to be definition of congruency. So I know that 1 and 2 make 180. I was told that, given. Then I know that 1 and 3 make 180. So I can jump and say 2 and 3, which are corresponding angles. So once again, I'm going to use, for my last reason, the converse of the corresponding angles theorem to say that's how I know they're parallel. And guess what? They're on the same side interior, so they make 180. Okay. Notice how my given is alternate interior angles for this. My given is same side interior. And I've proved that the lines are parallel by talking about corresponding angles. Okay. Last one. In the diagram below, measure of angle 1 equals 63. Mark it up. And QR is perpendicular to ST. QR and ST. That's right here. They've already marked it up. What would angle 2 need to be? What would I need to make the measure of angle 2 if I wanted to prove them parallel? Okay. Well, think about it. How are 1 and 2 related to each other? 1 and 2 are related to each other because they're alternate interior angles. Okay. So, I'm sorry. This right here is the alternate interior angles. Sorry. Okay, I was wrong. Angle 2 needs to be what to prove that they're parallel? If I say that this is 63 and this is 63, what would angle T need to be? Okay, so angle T would have to be 63 because then I'd have alternate interior angles. And I want alternate interior angles because then I can say, if they're alternate interior angles, then the lines are parallel. Then the lines are parallel. So here's my triangle so far. This I know is 90. This I know is 63 because of alternate interior angles. So I'm going to have to do 90 plus 63, 153. 90 plus 63, I know that all angles in a triangle make 180. So 27. Measure of angle 2 would have to be 27 degrees. Okay. All right. So we're going to talk about this again in class. All right. I'm given what I'm trying to prove, alternate interior angles, given same side interior, and I used the converse of the corresponding angles to prove that the lines are parallel. I found the corresponding angles in the shape, and I proved that they were corresponding. And then since that, I can then say, and the lines are parallel. Okay? So this is 2.2a. This is just the beginning of 2.2. And then tomorrow we're going to do a little more in this packet, what I didn't finish already. Okay? So this is good. We'll stop there. And I will see you guys tomorrow. Bye.